In this video, it's solving compound linear inequalities. A compound linear inequality is a combination of two linear inequalities that are connected by the word and or the word or. In and statements, the solution is any number that makes both inequalities true. For or statements, the solution is any number that makes one or the other inequality true. As an example, let's solve 3x plus 7 is greater than or equal to 8, and 2x minus 3 is less than or equal to 9. So the solution is to solve each one individually. So subtract 7 from both sides. On the first inequality, you get 3x is greater than or equal to 1. Then divide both sides by 3, gives x is greater than or equal to 1/3. And in the other one, add 3 to both sides. So 2x is less than or equal to 12. Then divide both sides by 2, and x is less than or equal to 6. And in between. So the solution is x is greater than or equal to 1/3, and x is less than or equal to 6. So this is saying that x is greater than or equal to 1/3 and less than 6, less than or equal to 6. So 1, 1/2, 2, 3, 5.9, and others make both true. Graphically, this looks like the following if both inequalities are graphed. On a number line, x is greater than 1/3. This way, right? And x less than or equal to 6. We'll start at 6 and shade to the left. Notice there's overlap in the two graphs. The overlap is greater than and equal to 1/3 and less than or equal to 6. If you only plot that overlap, the solution looks like the following. And so what you get is 1/3 to 6. In interval notation, the solution would be 1 bracket 1/3, comma 6, close bracket. Now let's try another one. Let's say we have 2/3 x plus 4/5 is less than 1, or 5x minus 3 is greater than 7. So for the first one, let's get rid of the fraction by multiplying both sides by 15. Okay, 15 times 2/3 x plus 4/5 is less than 15 times 1, which is equal to 10x plus 12 is less than 15. Or add 3 to both sides, 5x is greater than 10. Solving this, let's subtract 12 from both sides, so 10x is less than 3. Dividing both sides by 10, x is less than 3/10. Or divide both sides by 5, x is greater than 2. So the solutions for x is less than 3/10 is such that like -3, -2, -2.3, -1/5, 0, 1/9, and other values. Solutions for x is greater than 2 are numbers such as 3, 3.5, 5, 10, 25, and other values. Graphically, these look like the following. Drawing a number line. X is less than 3/10. 3/10 is about here, and it's just less than, so it'd be shaded this way. Oh, down. And greater than 2 is going this way. Notice these areas do not overlap. Since this is an or statement, they don't need to overlap. The solution is the union of these two areas, and in interval notation, this would be from minus infinity to 3/10, parenthesis, union to infinity. Let's try another one. Let's say we have 2x plus 7 is greater than or equal to 8, and 4x minus 2 is less than or equal to -3. Again, the solution of this would be solving each one individually. So 2x is greater than or equal to 1, and x is greater than or equal to 1/2. And 4x is less than or equal to -1, adding 2 to both sides, and x is less than or equal to -1/4. And this again is an and. The graph of these two inequalities is one, 0, 1, 2, 3, let's say. X is greater than 1/2. Greater than or equal to 1/2 would look like this. Bracket at 1/2 and shading to the right. X is less than -1/4 would be about here. Bracket and shading to the left. Note that and statements are supposed to overlap. These two inequalities do not overlap. Since they do not overlap, there is no numbers that will make both statements true at the same time. So there is no solution to this compound inequality. Another example, part D, 5x minus 6 is less than or equal to -1, or 3x plus 13 is greater than 1. For the solution, I will solve each one individually. So add 6, 5x is less than or equal to 5. X is therefore less than or equal to 1. Or subtract 13, 3x is greater than -12. X is therefore less than, greater than. I apologize for that. Don't switch the direction of the equality. It's just only if you're dividing by, multiplying by a negative number, and we're not, we're dividing by +3. So we get x is greater than -4. So we have x is less than or equal to 1, or x is greater than -4. The graph of these two inequalities is two. So x is less than or equal to -1. It's going to have a bracket at 1, sorry, and shading to the left. X is greater than -4 will have a parenthesis at -4 and shading to the right. Notice that these two graphs do overlap. However, with or statements, they don't need to be any overlap. In this case, a number like -3 makes both true. A number like sorry. A number like -5 makes one inequality true. and 7 makes the other true. So every number will make one of or the other or both inequalities true. The solution, therefore, looks like so far. Looks like this. Where every number makes the OR statement true. So the solution in interval notation would be negative infinity to infinity, which is all real numbers. The last example is 2 is less than or equal to 3x plus 5, which is less than 7. This inequality is written as in a chain. One can think of a chain of inequalities as two and statements. We can rewrite this as an and statement looks like 2 is less than or equal to 3x plus 5 and 3x plus 5 is less than 7. And then you can solve each one individually. So we get negative 3 is less than or equal to 3x. Negative 1 is less than or equal to x. And 3x is less than 2. And x is less than 2/3. Another way to solve this is to keep the chain and then isolate the, oh, you can also, by the way, sorry, you can now put the and statement back into a chain. So you'd have negative 1 is less than or equal to x, which is less than 2/3. Another way to solve this is to keep the chain and then isolate the variable. This means one needs to subtract 5 from the middle expression, but whatever one does to one part of the inequality, you do to the other part. So this would be 2 is less than or equal to 3x plus 5, which is less than 7. Now subtract 5 from all parts, and you get negative 3 is less than or equal to 3x is less than negative 7/5. I'm sorry, not negative 7/5. I apologize. It's equal to 2. It's less than 2. And then divide everything through by 3. So you get negative 1 is less than or equal to x is less than 2/3. Notice you get the same answer, solving it as a chain and solving it as separate statements. Either way is fine to solve, so it's your preference as to which way you'd like to do it. Both can be displayed as the following. So number line. Negative 1, which is going to have a bracket on it because it's less than or equal to, up to 2/3, which is going to have a parenthesis on it. And you shade everything in between. In interval notation, this would be bracket negative 1, comma, 2/3 parenthesis.